again. Welcome to the front-end crash course for Backstage. So we all know that front-end is quite complicated, but it doesn't have to be. And I think that by knowing that in advance, this presentation is very much to prepare you to navigate the huge ecosystem that the browser and the front-end world has. And I'm specifically targeted all the points to what you need to know in order to survive and be able to develop your own plugins for Backstage. So yeah, asynchronicity is hard to reason about. State is hard to reason about. We're stupid and we should plan accordingly. Meaning that something is when you know that something is complicated, doesn't mean you cannot overcome it, but it's better to know in advance rather than get the surprise later. And so I stole this quote from Dan Abramov. If you don't know who that person is, he's a very famous person in the front-end world. He created the library called Redux. I'm sure some of you heard of that. He's working at Facebook on the React team, last time I checked. I would also add a few ops lessons that we all learned the hard way. I mean, it's priceless what's in there. So if you want to be prepared about what not to do, it's also a valuable information. So okay, so the presentation will be split in 5 big parts. I will try to be as clear as possible. The first one will be, I'm going to talk about browsers and what they are, what they do, and how to use them, basically, when you develop. JavaScript, that's I think one of the most loved, hated language, but there is a reason why. React, very famous, and since Backstage uses React, it's a good idea to learn it as well. TypeScript, and finally I show you like Backstage and its plugin, and hopefully it will go okay. So browsers, we all know that browsers has been there since the beginning, like from the maybe late 80s, early 90s. I mean, the thing is that the spec for the transport protocol, HTTP, hasn't changed much in the last decades or so. Meaning that they cannot break a protocol, they make version of it, and they still have to support the previous one. So there is HTTP 1, there is HTTP 1.1, there is HTTP 2, now, which allows for multiple streams so you can download multiple files at once using the same connection. And now there is HTTP 3, which is a protocol over UDP mainly to gain speed. And so if you want to learn more about HTTP, it's very easy. You can open your browser tab, go to the network. So the first thing you have is this HTML document. But before, I'm going to show you a bit like how does this document arrive into the browser. So if you know curl, it's quite a nifty tool. And I prepare something. It's like a simple ping to the google.com with HTTPS. And you see that, first of all, he has to open a TCP connection. Then you have to exchange which protocol you're going to talk to it. Checking the certificate, TLS handshake, verifying the certificate, switching to HTTP 2, checking the user agent and the content. And you see here you have the HTTP code that is a redirect. And then at the end, you have the few lines of HTML that make the document. So there's a lot of stuff that goes under the hood. And this networking part is also very tricky. And this is what is the foundation of every front end. So now that we see how, all I would say, the underlying of networking a little bit, you finally get your HTML. The browser knows, even the oldest website from the 90s will appear in there. A browser is always backward compatible. No API has been broken ever. This is not Semver. This is not like maybe let's build it again to see if it works. No, if a website once use a feature that a browser put out there, it's out there. If it's in the spec, it has to be done to be considered a browser. And so many people complain about that, but that also means that in case of a zombie apocalypse, your little HTML will be able to transmit over the wire, and if you still have a browser with a running computer, you'll be able to read it. But that's not the point. The point is like the DOM. Do you know what the DOM is?
Document object model.
Exactly. So it's in the spec. It defines like basically you don't need to respect a lot of rules. It's very loosely in terms of requirements, but mainly the most common front end or most common web page in general, they all have a document type, an HTML tag, and inside that HTML tag they have a head and a body, and that's it. That's the bare bone skeleton for HTML document. And the reason all those framework and all this front-end ecosystem came to be is because writing to the DOM is not super convenient. It's quite a bit, I would say, not difficult, but if I show you this little... So I just have one simple HTML page here. It's nothing fancy. You see, it's like, it has a lot of JavaScript, but what basically it does, it says like, you can insert before or after if you select one. The thing here, you see that is JavaScript. It used this thing called document and then the query selector called before. You see a dot here. That means select me the element that has a class, that's the dot, that's called before. And that's this one. So by selecting, you can trigger events, and you have to apply a selector to select the element that you want. And that means that basically now the DOM is the state. To make change to the state, you can write some JavaScript. On top of that, you have events that occur. Like here, you see a click. So for instance, if I select this one, this is an event, it clicks. So you have to attach code to that event. And there is all that mechanism under the hood that gets triggered. So basically, the browser gives you the API to interact with the DOM. The problem is, when you do animation, you have tons of operation on the DOM. And so those operations are mainly blocking, meaning that until one is finished, the next one will not start. And so that creates a lot of problems for websites that have very big front-end application. And so what they do is they use JavaScript to animate all that. The problem with that is that it's very imperative. It's like, if this, then that, and every time you have to go check if the DOM has changed, because the DOM is the state. And so that created tons of pain for developers. And so now we're going to talk about JavaScript. That was the little bit like quick intro for browsers and what they're capable of in terms of providing APIs. So as you can see, this is the JavaScript reference. This is a book called JavaScript, The Good Part. As you can see, the size difference is quite huge, but I would say let's learn something from that. It doesn't mean that JavaScript is bad. It means that most of it is really difficult to manage. So the message, and if you read that book that I highly recommend you to read, the JavaScript, The Good Part, is 130 page, really great. I mean, simple to understand. Mainly, if you have to remember one thing about JavaScript is that don't use everything. That's what that picture says. You have a very thin layer of good stuff that you can use, and it's safe to use. You will be able to reason about it, all the rest is a minefield. So, you know, JavaScript was created in 10 days. So if you had to invent a language in 10 days, there's not many things you can do, especially at that time. So basically, JavaScript was a Lisp. And Lisp is only is based on two main ideas. One function that's called eval, that will evaluate a string and convert it to code. And the second one is apply, to apply function. So you can define function and apply them. And with the eval, you execute them. So that concept alone was started in the 50s, in last century. But that's the difference between a compiler and an interpreter. A compiler will take your code, parse it, tokenize it, and make it like compile it into machine code that you can then run natively on the operating system. An interpreter, such as Python, Ruby, all those things, they actually compile as they read the code. So that's not the same. That's why you can have runtime errors, meaning that because at the moment the code is executed, is parsed, there is the error occur. So that means that if you ship a code to the browser and that code has an error in it, it will appear on the client, not while you code it. And so that's the main difference. There is advantages and pros and cons for both, but that's just the quick story about compilers and interpreter. And the reason is it's very fast to write. Like you could write a Lisp in actually 10 days. It's not that hard. It's not easy, but it's not that hard. And so one thing that is brilliant about this interpreted language is that they come up with a new sort of concept that you don't have. For instance, in Java, you don't have, well, in the older version of Java, you don't have first class function, meaning that you cannot assign a function to a variable. You understand? This variable, give me one, is actually a function that returns one. Does that make sense? Like you can execute variable, which is it's a concept that is completely makes no sense if you think about it. But in this particular case, it allows you to do many things, meaning that functions are first-class citizen in the language, which means also that you can actually return function instead of value. So you don't have to write everything imperatively. You can delay execution to do later. So you're in control of the execution. And so, as you can see, this is a very basic example. You can just write a function that will return a function and call that function later. So you understand, here is the function that I define. Here is I execute the function, but this one return the function. And now I execute that function with another function that returns a value. So you decouple things, you decouple value from the execution, and that allows for a lot of pattern that you can use. Querying. So that's a little bit, that's how you use a first-class function. You have a simple function here that takes two arguments and they add it. So, it's no big deal. If you add those two, it returns what you expect to return. But with querying, here you will create a function that will add those values, meaning that you can do things in step. So if you execute here, you see the parentheses, that means execute that part. This will return the function, and then you execute that function with the 20 on it. And that allows you that will compute that answer. But you don't have to do that all at once. You can do that, for instance, first I want to create a function that adds 15. Just add this, and then you have your function. Then you can do some other task, and then you can compute the result. So you can prepare things so that when you actually need them, they are ready. And the way you organize that is totally up to you. But that's the basis, I would say, that's of functional programming. And that will become, like, why that is useful, it will become clear soon. Callbacks. Maybe you heard of it, but Node.js and the callback hell and why they invented promises and all those things. But actually, callback are really simple. It means that since function are first-class citizen, you can create a function and set a callback on one of the events that I showed you earlier, like what happened when you click something. So you can define those behavior and they get executed when the events occur. Now, you can actually do the same. This is a more advanced pattern. Like, you can create a function that will return a function which will be executed as the callback. And so that allows you for defining the common behavior. And actually, we can run that. That would be great. Here, so what does it do? Document query selector. It will look for the ID, the element with the ID delayed execution. This is the one. And when I click on it, you see that this is the old time. So the time, this is the old time. So I execute and get the time there. And then this is the new time. And you see that the two are 10 seconds apart. So, and that's the beauty of it. You can just prepare things, and at the last moment, poof, the last bit of computation that you need gets done. So that's why the functional programming is powerful. It lets you manage the execution of things at runtime. But then, you know, you have all this asynchronous. This is as well very difficult to manage. I put the link of two, one is a book by Dr. Alex Roschmeyer, and one is a talk, if you prefer video, by Christopher Porteneuve. It explains a lot because now you have callbacks, which would allow you to do asynchronous tasks very easily, but there are other constructs that, for instance, Backstage, React, and so on uses. And so this is what it looks like. So do you know what this does? Okay. So by the name of it, it's query the GitHub GraphQL API, which is, I'm sure, something you're going to do at some point. So notice that there is an async in front of the function. So I'm going to spend a little bit of time on this slide because it requires a bit of explanation because there is so many concepts here. So you have a function, but then you can create an async function. An async function is a function that returns a promise. What is a promise? There's such a long thread here. I hope you're going to follow. What's a promise? A promise is let's call it a thing that has three states: pending, fulfilled, or rejected. So pending means it's ongoing. Fulfilled, it means that you fulfilled your promise. Or rejected, meaning it fails you. The thing is that it allows you to write. So the promise is, you can recognize them by the then and the catch. So those are function. So you see, the fetch here is the API from the browser that allows you to go onto the network and fetch data. So this creates almost the same as this, the curl query. Yeah?
Is that that's not a part of the DOM model, right? This is not the DOM object model, is it?
No, the DOM is mainly No, it's not. It's it becomes let's say that it's a API available in the browser. It's well known. So there is this thing. Maybe I can explain that a bit. So in the browser, you have those ready-made API. You have this object called window, and this has a lot of stuff in it. So all the window object is available everywhere in the browser. But if you write it on the backend, for instance, in Node.js, this doesn't exist because you are on a, let's say, a headless browser. Does that make sense?
Yeah.
So I don't know if that is part of the DOM. The DOM for me is more the HTML and how you can interact with it. This is more the networking part of the browser. But because they are like...
Would it be correct to say that the
Like
DOM module is on the web browser and the Node part does not have the DOM module?
Exactly. So, for instance, I don't want to explain inheritance and prototyping, but that is, if you see window fetch, that's the fetch here. The fact that I don't put the window here is because the JavaScript engine knows that when it doesn't know something, it checks on the default object if any of those objects have that function to call it. So that's the only trick there is to a browser. There's a lot of implicit API that are there basically. And so this window.fetch, this is the same fetch as this one. That's why fetch is not in the Node.js. So far, so good.
Yeah.
All right. So let's continue. This fetch is going through the network. Is making a request, doing the operating system does the network, the rest, sending to the wire. I created a body here. So that's the body of the request. The request can be, you can send data with your request. Some requests, you don't need to send any data. You just say, here is my URL, just give me what is there. So that's a GET. That's what we call REST API. A GET is you just get things. A POST is you create things. A put or patch is you modify things. A delete, you delete things. And depending on which method you use, you may or may not pass a body. So get doesn't have a body. That's why you see sometimes that the URL, with a get, they have this question mark with many parameters. It's because that is kind of like considered a query. That's why it's called query parameters, so that the web browser knows that the URL going to specific handler in the web server, and that is passed with it so that the web server can figure out which filtering they need to do on the data. So, but in this case, we're using GraphQL. So that's a GraphQL query, is the basic one that you can find. It just returns me who I am. It returns my login when I'm on GitHub. And so you need to create an object that contains a key called query that contains the query. Then, because JSON is not, it's a JavaScript concept. It's not something that exists outside of JavaScript. Like, it doesn't make sense to the rest of the world. It's just JavaScript. JSON means JavaScript object notation. So it's a subset of JavaScript. It's very easy because you can actually parse it, or in this case, you can stringify it. Meaning, like, take that object and make it like just a string that doesn't mean anything anymore. But string are really good to be sent over the wire. That's the best explanation I can come up with. So then you have you always have some authorization and some token that you need to store somewhere. Mainly is in the header part. So you see those all those things here, content type. Those are the headers of the request. You have the header of the request and the response sometimes. So for instance, you can query something with a text and you can get JSON back. So those things are, it's not recommended, don't do that. But the main idea is really like, okay, it's decoupled. It doesn't have to be one way. All right. So we made our request. The problem is we get a string back because it's JSON, but not really. It's a string of JSON. That's why in the promise, we're going to unpack the promise, take what's inside, that's the string, and we're going to JSONify it, parse it mainly. So that's what this thing does. And then, you see, because once you are in the promise, you have to return a promise for some reason. You cannot unbundle the promise unless you use await. So await, what it does is that whatever is on this side, if it's a promise, I will unbundle it, take the value out of it, and give it to you. Does that make sense?
Is it the await part that is the stream, and the then part is when it's? Isn't that the when you have like a synchronous function?
Yes.
It delivers it back not as a full object. It delivers a stream back, right? Or is this?
It depends. Streams are another thing.
No, that's what I mean. So the await part is that the part that where you haven't got the full acknowledgement that you have got the complete package?
That's why I have the try catch here, meaning that, and that's why I bring this example because it has everything in it. So you have the catch here, which means that if this promise fail, is rejected, it will come here. If the fetch succeed, meaning I got the request back, or the error code is like an acceptable one, I will go here. The execution will go here. The await, what it does is it unbundle. It takes open the promise and take out the value. That's what it does. But if you don't have, how can I say? It pauses the execution. That's why it's called await. It means wait for that to either resolve or finish. Resolve or reject. If it reject, not by this one, by this one. If, for instance, the text, those things that you sent me back is text and I call JSON on it, it will throw an error. And when it throws an error, it's the try catch. So it will come here.
Yeah.
So you understand, that's why this is really complicated, and that's why I recommend that you look at that talk so that you see the evolution of each step, because if you try to grasp everything at once, it's really, really messy. But just know this: await, wait, and open up the promise. But you need to be inside an async function to be able to call await. Because in JavaScript, it's called the event loop. So the event loop means you have only one execution thread, and if something is blocking, it doesn't want to wait, so it continue executing. So you see all those things, they don't block until I tell him, wait, I need those data before you continue. Otherwise, it will return the result before we get the result. If you don't put the await here, the result will be a promise, because that's what the then return.
Can you do await on await?
I'm sure it's technically possible, but I wouldn't recommend. But that is the main idea of asynchronous JavaScript. That's why I show you this, because this is complicated. And if you create an async function, the worst part is that this, now that you unbundle it, it will rebundle it into a promise.
So if you have several async functions within a class, for example, that means that you never know which one. There can be like race conditions between the different.
Well, not with a wait, because you wait.
Yeah, but if you have more than one, and the one
It
dependent on the other one to be finished before you.
So there is also this promise all that says, okay, I have many promises, and I want to wait until all of them are either fulfilled or rejected. So that's why I highly recommend check out those information. This is not a full course on promises. Like literally, you would need like a few days to go through all that. I just want to point you, okay, this is the basic. This is what you need to know, and that the rest is for you to learn. So yeah, async is hard. State is hard. Keeping track of all the changes in the DOM is hard. That's why in programming language we tend to use immutability, and that means things don't change, and that's the why people are so like pissed at JavaScript, is that it does things in a way that you don't expect, unless you already know what's going on. So as you can see here, let's go through the code. I create a variable that is an object. This object has two keys, one RAM, one core. You see they have numbers, 16 and 8. What I do is I copy the laptop into a new variable called laptop2. Then I modify the RAM of the first laptop, so this one. And then I print them. And I compare them to see if they are still equal. What do you think?
Probably will be equal.
Yeah. But then I print what's happening. As you can see, the main laptop, the original one, has 2. But why the second laptop also has 2? And moreover, why are those 2 equal? So one thing that will really save you hours of banging your head, there is no pointer in JavaScript. Like you cannot define a pointer the same way as a pointer in a language point in a certain area of memory, because in JavaScript everything is a pointer, except if you use string, but that's another string and the basic type number. So that's the point. The thing is that look at it this way. It's a pointer. So here I create a pointer to an object. Here I copy this pointer to another object, to another variable, sorry, and then I modify the object. So of course you have 2 things that point at the same thing. I never copied the RAM, the object with RAM and core. I just reference it from 2 different points of view. And that's a mess. Like this is why bugs occur, is you have 2 things that you think are different, that point to the same thing. You modify one, suddenly the flow of the program makes no sense at all. And so immutability, if you remember one thing from this, is this: immutability will save a lot of headache. It might not be as performant or whatever. I know there is a lot of, if you do like real high load or the front end has plenty of requests that needs to be made, maybe immutability is not your use case. For 99% of your use case, immutability will save you. So now we're going to React. because the problem with the DOM is that all those operations, they are synchronous, not asynchronous. So if I say create me a new image down there, it will block the execution of the page until this image is created. So the problem with that is if you have a lot of operation, your web app is completely useless because it will freeze all the time. And that's a really bad user experience. And if you're an e-commerce site or, you know, a casino company, those front-end, those bad user experience are actually directly translated into revenue. So what people in like the early in the past decades decided to do was, okay, you see that this you have an element, then inside that element you have a child element, you have another element, and in that element, and this is kind of a tree, right? Is you have the root of the tree, then you have the children, and those children have children and stuff. But those are actually data structure that are very familiar to programmer. And so they say, well, why not have a copy of whatever is happening on the DOM and do it into a virtual DOM, which is just a JSON, an object, like the same as the laptop I showed you before. This object contains like, oh, hey, okay, I have children. Here are all my children. Those is also have some data and children. And so instead of hammering the DOM, we can do all the change we want, and we let React or any virtual DOM library or others do the diffing. So they do the difference between what is the virtual DOM and what is the DOM. And what they do is they batch those with very precise frequency. Because, you know, it's like the frame rate of your TV, you know, it's like, or your screen, it's like 60 hertz, meaning that 60 times per second the screen is refreshed. So, I think it's below 27 that the eyes start to notice that you have that is slow. And so this thing is very precise into the way it has to do these operations, like batching those changing to the DOM, so that the eyes doesn't understand what's going on. It just see something flawless. It's like a movie, you know. And so that's the main idea why React came to be, is that it's a very efficient at diff, making the difference between a tree and another tree. And so you get a very nice user experience with that. And so they even went further and say like, okay, well, I don't want to have to write a function every time I have to create an element. So they created GSX. I'd say they, I don't know who they are, just so we're clear. But, so just imagine, you have, this is the main function to create an element from React. The other one is the document.createElement, you know, h1. That's from the browser. But from React, you do that, it will actually modify the virtual DOM. And then the virtual, the diffing algorithm will make the difference and only apply the changes. So you don't have to repaint the whole picture all the time. And so those two lines, those two, I would say, expression, actually give the same result. And to show you how they do it, because this looks very familiar to, this is HTML, but you're in JavaScript. So they call it GSX. I don't know why. And so, oh no, come back. So there is this really neat tool called the AST Explorer. So abstract syntax tree. This is what happened when you have a code that is like a JavaScript, and the interpreter needs to parse it, meaning that he knows that, okay, if I see var, that is a keyword, and the next word after that is the name of the variable. You understand? And so they build this tree of objects, of data about the code. And there's a tool to see that. You can create in many languages and everything. It's quite neat. But if I paste this, you can see that this is actually the JSON object of that program. So this is the abstract syntax tree of this. And if you look at it, it detects that it's a variable declaration, that it's a variable declarator that has an identifier of identifier. The name is element2. It's a JSX element. It detects that there is an opening element. That's the H1 here. So you see, it gets yellow. An identifier, a closing element. So you see, like that's how they do. And what they do is a compiler work. So basically, JSX is kind of like a pre-compiler. They call it transpiling. What they do is they transpile this into this. And the reason it works is because it's mainly data. You're shuffling data all day. And so since you have data about the code, why not, optimize the code that way? So that's where the JSX comes into play. Whether it's beautiful or not, it's a totally different topic, but at least you understand the basis of, where this comes from, what does it mean, and how to use it. So there is also, and so now we getting into the world of React, right? You saw JSX, you saw why, you saw how. A React component, it's in its more simple form a function. So you remember at the beginning we saw the function and how to use it and how to querying it and delay the execution and everything. You can also use class, but I would say there is a caveat that class will surprise you into their behavior. I don't recommend using them unless you really, really, really need to. Yeah, that's just my preference. You remember JavaScript, the good part, why it was so small? It's because class was not in it. That's, you make your own decision. So this is how you create a React component. You declare a function. Note that the first letter has to be capital. The reason is you don't want to collide because the React doesn't know if it's a browser element or if it's your personal element. The thing is that it's also for performance reason. Just imagine if you, every time, for every JSX tag, you would have to check if it's from the browser or not. The browser is a quite long list of elements. So you say, okay, let's use that convention. Put a capital letter in front. So you see, you have those props. It's properties. So they shorten it into props. And this is how you pass the prop. So the name here is the name there. And you have your first React component. And that is if you don't have anything in the middle, like the H1, you usually put something in between the opening and closing tag. But here, because you don't, it's just this one. It's the same as the closing one, more or less. And so this is the first React component. And the reason this took over the world is because they are really composable. Like they are very tiny and small, and you can do a lot with them, and it's easy to reason about. You don't have to keep the state of the whole application in your head to be able to reason about that little thing. So the beauty of it is that since you can compose them, it's easy to change things, or easier, I would say. So here, you can reuse the same component with different parameters, different properties. And here, this is how you render the component. So you create an app that composes those components, and you call React and say, please render this. And I have an element that is the ID root, and paste whatever the virtual DOM has into that one. Here you go. And so when you say that, it means React is in charge of that root. So we call it root. Name it whatever you want. And that's the thing. You don't have to. It's not a framework. It's a library that does virtual diffing, and it's really good at it. It has a lot of options and a lot of tooling over it. I also put a video by function, composition over inheritance. I highly recommend you watch that one. It's 5 minutes, beautiful. Basically, it shows like why composition is easier to reason about and to change than inheritance. So composing makes things easier to change. Inheritance makes things very static. And so you're not done because, maybe you, as I said, you add a event listener that listens to click, and that click, because now you have a diffing, your component might be removed and added to the DOM. So just imagine you have a list. So a list of names, you have the element, the list element, and you have all the entries. Let's just say you add one. You have created a new element, and if you add a click on that, then you remove it. The browser doesn't automatically remove the event listener. So that's why you can have memory leaks into your browser, and you see like those apps, if you leave your browser open for too long, it's just like growing like crazy and eat all your RAM. This is because of those little thing that keeps bubbling up. They are very small, but if you do that 1,000 times per second, it grows out very quickly. And so the idea is that the components also have a life cycle, meaning that you have a function where you can write things in and say, okay, whenever the component initializes, I want you to do this. Whenever the component is mounted, meaning written to the DOM, I want you to do this, like go to the network and fetch something. Whenever the component is updated, you might want to do, like for instance, a common use case is that whenever you see a component update, you want to check if the component, the data that you get is still the same or not. Because if it's not the same, you know that the DOM will be changed, and it will trigger a new execution to the DOM. But what about if it's the same data? Why do I need to change anything? So then you gain into performance. So don't bother too much. I just tell you that the components have a life cycle and that they are created and destroyed, and you might not understand when and where those functions are executed. The thing is that this is still state, right? And state is hard. So what they come up with is that, okay, state is hard. Let's take it out and let's put Redux. Redux comes from it's made by Dan Abramov, the guy from the quote earlier. And it's a very decoupled way of dealing with state. And basically it can be summarized as this. It's a one-way data flow. So just imagine your browser, you're clicking around. Those are events, but here we're going to call them action. So when you click, it dispatches an action. It dispatches an action. That action is actually just a JavaScript object, right? It's just like the type of this action is click, and the payload is like, I don't know, whatever you want. Then we have the thing called the reducer. What the reducer does, it reduces the state by using an action. So maybe it's easier if I show you an example of what it is. This is a reducer counter. So if you see the action increment, reduce it to adding one. If you see the action decrement, reduce it by removing one. And if none of them are, just return the state as it is. So why is that interesting? That it actually creates a new state. So you have immutability. The thing is that since you have all those, it's a nice way to decouple whatever state of your application from the state of the component. So if your component holds state, it's kind of difficult to figure out what is the state of inside that component, because they can be written and removed and added and updated and so on and so forth. And so once you get a new state, this state is actually what we call is contained in the store. And the store, you can subscribe to it. And you can execute a function every time the store changes. So every time you get a new state, the store change and execute that function, which is brilliant because now you have the whole flow that is immutable. And so when that function gets triggered, you can call React and say, hey, I changed something, do the diffing, and go apply that to the DOM. And so now you have the whole cycle of, okay, a user made an event, you have an action, you change the state of your application, the state is changed, you tell React, the store tells React about the change, and React go and apply the changes. And so the user sees. And so now you have the full cycle of how this React Redux frontends, like the gist of how it works. But these days they change because they replace that with React hooks, and it's very neat pattern, I would say. Is just something a simple example is that instead of using a global state, you know, because it can change by everything, and every time you have to create a new one, and they might get quite big, so you have to split them and so on. And so sometimes you just want to, okay, I just have a little counter there, I don't want to, you know, do the whole thing. For every line of code you change there, you have to change things all over. So they come up with the concept of hooks in React, and there are many of them. You can even write your own, and they are it's in the React library. Like this is from the React library. It's a function that when you give a default value, it gives you an array of two things. It gives you a variable containing that value, and it gives you a function to modify that value. The reason they do that is so that they can React can know when things change directly. You don't need to go through the store, and React can optimize for that. So you get much better integration with React in that way. It's yeah. I don't have any opinion about it. Use whatever you're comfortable with. It is just fine. You like, it's worth to learn it, but it's not like mandatory to use them. That's what I mean. It's the latest of the brightest, and it's worth learning, but it's not.
Any use case?
Yeah. To keep state. So before you had to create a class and create a variable on that class and store it on that class, and then you had to create a render function. Here, the thing is that it's just function. And function are much more composable than classes. And so the idea here is really like, okay, I have some state, but I don't need to store that into the global state of my app. I just want that little, for instance, I'm trying to think, but forms have, you know, if you have a form, it's like, is it an email? Is it? You don't want to, every time someone types something, you have to go through all that stuff, you know, like create an action, reduce it, change the store for every keystroke. So yeah, it's more like doing extra validation on form is really useful. And since if you don't have form in a web app, like what else do you do? There's not many other use case for that, for something you cannot input data. And so now you saw like the immutability for the DOM is something like React. There's many other, Vue, Angular, Svelte. Knock yourself out. Immutability for the upstate, you can use reduct or hooks. But now, what about the shape of the data? Because your state might become quite big, and if you change something in the state, how do you know that that change will be reflected in the UI and everything? So Microsoft came up with a TypeScript. This is where it comes. TypeScript is a superset, a typed superset of JavaScript. So if you write TypeScript, you transpile, it's compiling, you transpile it to bare JavaScript. The advantage of that is that you have strong typing, meaning that if you change a type, the compiler, the TypeScript compiler will detect that the type that you're using is not the same as the type elsewhere that everybody is referencing. So it's really hard if you have, let's just say that, okay, here I pass a number, right? What is it to say that I cannot add a string here? I say I don't care, I just want to set count on a string, and then this will become a string, and then it's a mess, because, you know, like in JavaScript, you can do stuff like this. Like you have, I take a string, and then I add 1. Okay, 1, and if I do the opposite also, but if I do 1 equal, that is equal true. But if I do 3 equal, is equal false. And so you have what they call type coercion in JavaScript, meaning that if you just put 2 equals, it will just say, okay, they kind of look similar, it's true. But if you do 3, it's like, no, I want to be precise. I want them to check, like, is this really the same type? And so you have all those quirks that with TypeScript kind of like let you know when those quirks. And so I think people like TypeScript because it tells you while you're coding. It's a compiler. It's not like I don't need to debug into the, monitor the app into the customer web page. And so you save time with those things. Basically you avoid a lot of typo. They should have called TypoScript. Really. Imagine this JavaScript but with more Java. And that's what it looks like. Let's say you have a function that search and you pass a name or an age for if you search for someone. Well, in TypeScript you can define a type person, and you can say, okay, the name is going to be a string, and the age, it can be a number, but if it's not defined, I'm fine with it. So that's the question mark there. And it returns an array of person, and person is of this type.
But TypeScript has a type of any, right?
Yes. But that's just JavaScript. Like, that's the thing. You can write complete JavaScript in TypeScript. It will let you do that. That's not the point. Like, it's no use if you do that.
But is that the default behavior of TypeScript if you don't declare it?
Yes, I think so. I'm not fully sure about it. To be honest, I always put a type somewhere because of typo.
Does it have any performance issues if you use it?
No, because you compile it. So it only checks while you are in your editor.
If you use the any.
I have no idea about that. Seriously, that's all I know about TypeScript. Is like, use it. You're gonna say, if you're more than one person using that, I would recommend using it, because if somebody changed something somewhere, you will see it directly in your code, and not like, oh, what is that schema that you use? Why do you put a boolean here and not a number? Like, it's just avoid useless communication between the teammates. It's just like, okay, we have that type, use that type. Here, it's convention. I like it. It's kind of like, all right, you can communicate by code. Otherwise, just imagine, here you have to have a if this is string, if this is not null, if this is like, it's like, and you have to remember like all those quirks. I show you about the 2 equal, 3 equal. JavaScript is full of those. So they say like, okay, we're going to make a new language with a type, same syntax almost, and this will going to compile to this. I think if you learn it, it's like a good, I would say, safety net. It might feel like a blocking at times, like it might becomes annoying. If it becomes annoying, just remove it.
But I don't know, in Swedish it's ordning och redo.
Ordinavera?
Ordning och redo.
Oh yeah,
Order.
order, yeah. But that's about it. Like, because JavaScript is a loosely typed language. You have a few type, like, I don't know. We can check actually. It's you do type of, and then you do like a null. The type null object. Like, do you see what I mean? How can you? But if you do like, this is also an object. This is a string. This is a number. But then, again, if you do 0 equal false, it's true. So you see that all those quirks becomes quite, they add up. And you're gonna have a bug somewhere and you're just like, oh yeah, I remember when you know. And that's why they always recommend put 3 equals. So that it doesn't mess up your, you're sure that what you compare it with has some sense. And so now we're gonna bundle everything together, like TypeScript, React, hooks. Yeah, that's from the To-Do app. So this is what I mean. Like, you define an interface that has props, that has a path, that is of type routes. I didn't define that here. I took it from the To-Do app example. But then you create a variable, and that variable is of type react.fc with the type. So this is a generic, meaning that it's like you have, how to explain generic? Maybe I will not go that far. Let's keep it at that. That you can define the shape of a type that way. So FC is function component. So you see, this one is a function. And so you have a React function component that takes as a parameter props. Props is defined as that. That means that it's an object with path defined in it, and that path is of type routes. And so now you have this. This is a type use. That's a hook. When you see use, it's usually hook. App state. So it's of this is the type of the state of your app, and then you have parentheses there. But it will returns the state. This is the state of your app, and this is how you modify the state of your app. So in here, you see that you have in that state you have a list, a to-do list. It's a key in the object, and you map over, meaning it's a list, and you want to change each and every one of those lists. And those elements in the list are to-dos. And those to-dos apparently have a completed field that you assign with this value that comes from this element. And that is a React change event HTML input. So if you have a input box of type checkbox, if you click in it, the toggle checkbox function, which I could not put here where it is used, but it's inside a toggle. It's inside a checkbox, sorry. Will detect that the parameter, the argument of that function is of type React change event HTML input element. It will return the type void, meaning it doesn't return anything, because it mutates. It just called this function, and this function doesn't return anything. It just set the state. And the state is of that shape now. So it takes the previous state and it changes it that every one of those to do are now checked. So it's like a global check when you want to, you have a list of stuff, and you understand. It's like, and if you change something, the TypeScript compiler will hopefully tell you like this has changed. Please make the adaptation. It's kind of hard to read with all the types, but you get used to it. Build step. So yeah, because now you have compiler, you have probably some CSS preprocessor like Sass or post CSS or whatever thing. Then you have image. You know, you have to optimize your image so that they render fast. You have to compress your JavaScript so it doesn't bundle up into a massive amount of gigabyte of things. And so that's what bundle are. This is like, I mean, I think if we add the time all the developer in the world has spent to bundle their code, you see the value of a compiler at that point, you know. But it's very well done. Whatever you throw at it, everything is optimized. The nice thing is that if you want to start, there is this project called Create React App, and that already has a pre-configured one. Like you literally don't need to change anything. Just go through the tutorial to see, but it's no, like you don't need to learn Webpack. That's all I'm saying. It's quite tedious, but it might be worth it. Course. I'm so sure that we have full stack developer because nobody wanted to teach backends developer about course. Course is what happened when you have a front end that's not on the same domain name as the backend. You can see here. So I have an image that's on domain A. Let's say that this go fetch to domain A, but because we are like this document is on domain A, I cannot fetch things the way I want from domain B, you know? But just imagine it's a security concern. You could host something that actually you fetch for somewhere else, which is, and so that's an opting mechanism. Like you need to enable the cores. So cross origin resource sharing, so that the backend will work. And so if you're working with a front end and the backend is on a different domain, they have to activate the cores. Otherwise, you won't be able to talk to it. And I can show you a quick example. So
like you trust to the origins, and then you can actually share.
yeah, that's what I mean. Like they have to open up themselves to you, so that the backend has to allow you to query that backend. Does that make sense?
Yeah.
Yeah. You can whitelist per domain. So if, for instance, I can allow your domain to query me, but not the other domain. Do you have any
done at the code level or
browser? So I'm showing you that now. So I'm gonna query Google, right? This is the message you're gonna see. It's like, has been blocked by course policy. No access control allow origin. That's because in the networking here, the networking request, how do I remove this? In the networking request, here in the response, there is no course allow, there is not the, what is it called here? You need to have access control allow origin as a header of the response request. So the response request, response header, it's not there. And that's what the browser is complaining about. Yeah, but that's something that has to be activated. It has to be enabled on the backend. You cannot enable it yourself.
But is this more between the web server and the browser itself rather than the code?
if you write a web server in code, like a JAX-RS or like a Python Flask, or like you need to actually add that header onto the response. And there is plenty of libraries that allows you to do it, but it's an opting mechanism. It's not like you cannot do anything unless you ship your own reverse proxy, meaning that since this is a browser, you have to create your own server that goes fetch that request, that API data, get it, and send it back to you, which is a pain, really. I needed to access some data that is on a service. And I try, and I get that message. No, can't you just ship a reverse proxy? And so what I have to do is take my front end, bundle it into a container, set up the CI/CD, do all the Kubernetes manifest, configure the Nginx proxy, so that he can, whenever I query the Nginx proxy, he actually goes and fetch the data from that service, because I cannot do it directly from the backend, from the front end, sorry. And so that's why I'm putting this slide here, so that you know about it, that people needs to know, backend people needs to know about this. Yeah, it's a debate. Like, people need to know to be able to debate those things. CSS is also something a lot of people struggle with. I think it's worth investing time and learning it a bit, like properly, and that will remove a lot of friction later, because it's not that complicated. You understand? Like, once you get it, you have a few things you need to remember, and you just move on. It's like done. You don't have to. It's basically the same as JavaScript. So once you know JavaScript, you're pretty safe. You understand what you use, what not to use. You can build anything into the browser with JavaScript. So this is the basis of actually, it's not the base. It's very just a few features that CSS is really nicely, where they really nailed it. First is the CSS variables. So before, you needed to have some preprocessor like a SAS, or those CSS preprocessor like PostCSS and everything, and they made it so that it's the same as TypeScript for JavaScript. They took that SAS or SCSS and compile it to CSS. But now CSS is catching up. You have variables. You also have media queries. You can even set the theme. Like, you can tell a media queries if it's using the dark theme or the light theme of the operating system. So a media queries is basically, it's like an if statement in the CSS. Like, it's if it's only screen. I think you have other like tablet, or I'm not familiar with those. How do you say? I'm not an expert. I don't know those things. I have to look them up all the time. But I know that the maximum width of that screen, if it's 600 pixel, this background will be light blue. So yeah, take it for what it is. It's to make those design responsive, so that you have the same website that is available on mobile, tablet, and desktop. And that allows for, yeah, and the thing is that with those variables, it's funny because you have to put double dash before the name. I think it's for compatibility reason, or the parser, so that they figure out, like, okay, this is a variable. And you have to call the var function on that. You can also do some light calculation. So if you want to do some, like, the size of this is, the unit thing is madness. Like, seriously, you have like rem, pixel, centimeters. Just to figure out the unit system is already an achievement. And they mean different things in different contexts. I think there's like 26 available units type. Like, so Yeah, but now if you catch up with the latest, I think everybody's using rem, which is the relation of to the font of the screen, so that you can keep things like readable according to the size of the font. So if someone zoom, the design stay the same, and or the ratio of the design is kind of, the proportion stays the same, and it's totally worth learning. Like, invest 1-2 days, just go to MDN. You know, they have a really nice introduction tutorial. It will save you hours and hours of head banging later. So MDN is the Mozilla Developer Network. That's my favorite reference. There is example whenever I need to remember what's that element for, what's that CSS variable for, is it supported in every browser or not. So yeah, I really like that. So now we are getting serious with Backstage. That was a long ride. I hope that so far you understand that, okay, things are complicated, but they actually, it's possible. It's possible to master, that's what I mean. And so first I did, yeah, I went to the repo Backstage and I started to do like yarn install and stuff. You can go and grab a coffee, like you can come back in a while because it's a lot of code that is bundled, which is kind of inspiring in some way that, I there's a lot of building blocks that are already there. Like, you don't need to reinvent the wheel, and that's why I do this presentation, so that with the request I showed you, the promises, the function in JavaScript, the little bit of CSS, little bit of React, little bit of TypeScript, you should at least survive into knowing how should I know, where should I look for what I'm, like, at least get the keywords right into the search bar when you're looking for something. And that's the best I can hope for, because I don't expect you to become like front-end developer after this presentation, but at least you will have a way, a common language to get those, you will be able to ask questions easier. And so what I did is exactly what's on this. I cloned the repo, I changed dir into it, I install the dependency, I start Backstage, and I created a plugin, which is called plugin 1, first plugin, yeah. And so you see that, I don't know if you see, but I see, this first plugin is actually a React app with TypeScript. And so it's already pre-configured for you. You don't need to do any messing around. Everything seems alright. You have the Backstage CLI that will help you build that plugin, and so no webpack, no crazy build step, nothing like that. TypeScript is already set up, so all you need to do is, here. So that's your plugin. And that plugin is defined here. And as you see, this is how you import from other files. So when you see that it starts with a dot and a slash, that means that it's a relative path to something here. When it starts with something else, like a name, or in this case, that's a namespace. And inside that namespace, you have the package called core. And those are in your dependency. So when you do yarn, all those stuff are downloaded and set into into the file system, so you get access to the code. Since Node is an interpreted language, it just reads the file and compiles it as it reads it. you don't have the compile step, but you want to optimize it. So that's why you have those build steps that are quite tedious sometimes. And so yeah, that's how you create your first plugin. This is all the code there is, and you see it's called register root. So I'm not sure the backend. No. So here I have to do yarn start. Might take a while. It's going to build everything, and then you will see that the UI of Backstage is going to start or not. Yeah, so that's a typical thing. When this happened, I don't know what's going on, but I know how to solve it. So I'm going to remove all the dependency and reinstall it. And now I need to recreate the plugin, probably. Oh boy, there is a lot of things. It's gigabytes of like those things. It's going to take a while, but in the meantime, I can show you what the code looks like. So you can see that I have this example component. It's not going to find it. Example component. You see it imports React, and that type, that is function component. And so you see that this example component is going to take as it's a variable of type functional component that has an argument object. So you just pass something. And there you have the theme, and the theme is material UI. You also have Backstage core. And those are like whatever. You want the content, you want a header, you want those things. You just plug them in and configure them. So that's the beauty of those components, is that they are reusable. And then you have the grid. You can define a bunch of stuff. And you see this one is interesting. Example fetch component. Because they know that the hardest thing is to actually write something that fetch data from somewhere else. And so this is TypeScript. So you have the type user, and this is a huge thing. But imagine, this is already big. Imagine if you put a typo in there. You know, the error message might not be super easy, but with TypeScript, it kind of like figure out, like, okay, the state doesn't match what you tell me. And so this is a dance table, okay. Somebody calling. So as you can see, that was quite an experiment. Oh no, not npm, yarn start. TS node. What has changed? Package lock. What does package lock change? Okay. I did npm install. Not good, not good. So yeah, that's one of the things. Wow. Yeah, so there is a few dependencies. It's a really, really massive project. I think like that front end is like one of the biggest things I've ever seen. We tend to like break things down into like smaller or separate things, but here is like it's an architecture. It's a plugin architecture. So you have the core that contains everything, like the theme, the component, and that's really nice. Actually, it's a lot of work that's been done for you. And so all you need is to come, take those components, glue them together, add the API that you want to talk to, figure out the authorization, authentication to the backend you're talking, getting the data back and display. So it's not that much of a stretch. Like a lot of work has been done for you here, and I think I think that Backstage project is going to be a really successful project because every company has some kind of back office that is crap, and this will like level up the play. It's like Grafana for monitoring. Before that it was, I don't know, they had Graphite. Have you seen the UI of Graphite? And so like this is like next level. This is the beginning of something like it will, because it's open source, because there is Spotify backing up this project. I think this is going to be the same as the Grafana did for Graphite. It just explode into usage and use case. But yeah, you need a really powerful PC, and so you see what it's doing now is to figure out which dependency and compile those dependency and do those. Like, I mean, we're almost at the level of a compiled language, right? This is wow. You can say whatever you want, but I think ooh, I only have 6% left, so we're gonna do the script. Okay, what are the create plugins? Yes. Or can I run it now? Because I don't think. So yeah, it doesn't work with npm. You have to install yarn. I'm not sure what is the best way to install yarn. Maybe it's your package manager. Maybe it's with npm. I have no clue. It's such a black box to me these days. I used to know all that stuff, but once you let it go and move to something else, you come back and it's like, what have you done? Who was in charge here? Yes, and that's the beauty of it, but I'm not sure how. Yeah, you can use your plugin. I don't know how you can make it work though. You understand? Like those quirks. You see the JavaScript equal. There is no such thing as just in this IT business. It's just all about like details. There's one little detail somewhere that changed and the whole thing blew up. And so right now, so that was just installing the dependency. Now I'm going to try to run Backstage to at least show you what it looks like. Cache miss need to build. Yep. But this is like that's the main, that's the truth. Understand? Like this is building, and you know what? If you, because they have all those things, every time you make a change to your code and you have to wait for sometimes for the things to be built, and this is like getting really hard for developer experience. Success. So I think that in a few years we're gonna have going back to the roots kind of stuff where, this thing has gone too far. Maybe we should do something lean. It's a cycle, like you keep adding until you cannot add anymore, or it's like too painful. And then somebody comes and say, oh, by the way, here is all you need. You don't need that much because it's the layer of abstraction. I hope that I can show you before my PC dies. Oh, yes, yes. So that's mainly the Backstage home. I wonder is first plugin is there. Yes, no, this is the error that you should see if you have yeah, exactly. But it's kind of nice. I was hoping to see. Ooh, explore. Nope. Create. I'm discovering that with you. I have no idea. This is the new version. I just git pull before starting. Maybe that was. Yeah, I think so too. But what was the plugin? Yeah. So enter the idea. Plugin one. No. Yeah. So plugin one is being created. All right. I hope it's the same. But now we install the dependency of that plugin, and yes. Now do I need to reload Backstage or something? Okay, plugin one. Yes, so this is the plugin. So you can see this is the dance table. So you have the example component, and then you have the example fetch component that gets from random user.me. So this is a plugin that fetch the data from a random user, get it back, put it into give that data to the React component, and React renders it. And as you see, it went quite smoothly, I would say. So let's see if we can plugin title. Where is that? Before. Do I need to do something? Build plugin, okay. Maybe I need to restart the Backstage. I'm gonna stop after that because this is the end and you have all the tools already to start your journey in the front-end world. I just hope that this will be useful and that you can make something out of it. Like try it, try to get the random user. You got it. So great, this has worked. We can, let's see if I can do something. So you have the example fetch component. Yes, go get it. So yeah, you see the await fetch response, then the response, you apply JSON to it, then you get the data, then you get the result. Yay. That's all I had, I think. Yeah, so that's the main thing about the plugin. You see that now you know that it will return a promise user. No. Okay. Okay, so you have a hook that's called use async that allows you to define an async function that will return a promise, and that promise return a user array. So the square bracket means array in JavaScript. And that's it. And then from there, you get the you get an object with 3 keys in it. You have value, loading, and error. And you can see that if it's loading, show the progress component. If there is an error, just throw an alert. And if the thing is not loading and there is no error, just display the value or an empty array. And you have the dance table, and that dance table is this one. I wonder if that is where is that defined? Okay, there we go. So let's see, maybe I can, we don't need the nationality here. It's so sad that I need to, I don't know what I should do to get, compiling, okay. No! But that's about it. The battery is almost dead. Yeah,
We trust you.
power. Okay.
We trust you.
Good.
Very cool.
I hope that you enjoy it.
Yeah, very much.
Thank you.